Welcome to Intermediate Algebra, Chapter 1, Section 6, where we are going to talk about absolute value equations. It's exciting stuff. And not too difficult. Just a couple little details we have to watch out for. So here's a 5-step process that you can read through and examine. But what I'd like to do is get right into the process of solving an absolute value equation. And actually, before I do that, I want to point out that if I told you that the absolute... I have to enable the pen first. I can only remember so many things. If I told you that the absolute value of some number m was equal to 5, could you give me an m value that would satisfy this statement? The absolute value of what number is equal to 5? And some of you are thinking, well, the absolute value of 5 is equal to 5, and you're correct. And then some of the rest of you went one step further and said, well, the absolute value of -5 is also equal to 5. And you'd be correct also. Apply a similar line of thinking to the expression that's inside these absolute value bars. I need for the stuff inside these absolute value bars to equal either 16 or -16. So 3x minus 2 needs to equal 16, or 3x minus 2 needs to equal -16. That's some pretty reasonable, straightforward thinking, I would say. And now we need to solve both of these little equations for x. So I'm going to add 2 to both sides, so that 3x is equal to 18, and then I'll divide both sides by 3 to get an x value of 18/3. I don't know what that was. And I'm going to leave it in fractional form as an improper fraction. And then in my other equation, I'm going to add 2 to both sides, plus 2 and plus 2, so that 3x is equal to -14, and divide both sides by 3, so we get an x value of -14/3. And these are the two solutions to your absolute value equation. But it's this beginning part of the process and remembering to split up or write out two separate equations, neither of which have absolute value bars, as the very first step in solving an absolute value equation. From there, you know how to solve little linear equations like that, no problem. What else have we got? This problem, as is the case very frequently in mathematics, as we continue learning more about a particular topic, the problem gets more complex, but we make it more complex by adding additional steps to the beginning of the process. So here, the very first thing you should do is subtract 2 from both sides in order to isolate, what is wrong with my brain? In order to isolate the absolute value. And now you've got a statement that looks an awful lot like the previous statement. And you take this and you break it up and turn it into two separate statements. 2x plus 1 equals 3. 2x... I'm tired. I might be a little burnt out. Keep an eye on me just in case I make an arithmetic mistake. I can't even read, it seems like. 2x minus 1 equals 3, or 2x minus 1 equals -3. And then you'll solve those two little statements, and you'll have your two little solutions to this little absolute value equation. I'm ridiculous. Can I apply that same process to this problem? Absolutely. Equals 4, equals -4, carry on. What about this one? Definitely. Except this has an additional step before you can get started. We need to isolate the absolute value. I'll do that by multiplying both sides by 2, so that the absolute value of x plus 1/4 is equal to 6. And then you take it from there. Turn it into two separate statements. The first one without any absolute value bars is equal to 6. The second one without any absolute value bars is equal to -6. And solve from there. What about this problem? Can I do the exact same thing? For sure, except you have two things that you need to do first in order to isolate the absolute value. Add 7 to both sides, and then divide both sides by -3. And then this will be all alone, and you can begin solving your absolute value equation. What about this one? All right, you're getting the hang of this. You feel like I don't even need to tell you anything, do I? What do you think of that? Piece of cake? You know what to do next? What do you do next? Are you thinking split it up into two separate equations where the first equation is equal to -2 and the other equation is equal to +2? If that's what you're thinking, you're wrong. Sorry, I walked you right into that one. Is it possible to take the absolute value of something and get a negative number? Please say no. No, you cannot. This problem, after doing the first step of the normal process and realizing that when you've got the absolute value isolated and that it's equal to a negative number, there's no way to make this a true statement. There isn't an x value that's going to satisfy this statement. So this answer is no solution. Can you imagine someone giving that to you on a test? They would really try to trip you up like that? A math teacher? Definitely. Solving equations containing two absolute values. It's the same. It's really the same. I'll show you this one, but I mean, look, really? Look at this. Does this not look exactly like what we've been doing? We're going to take this thing and split it up into two separate equations. The first equation says 2x minus 5 equals 3x plus 7. It's as though I just copied down the equation and got rid of the absolute value bars. That's what I did. The other equation says 2x minus 5 equals the opposite of the entire right-hand side of the equation. And then the first thing that you would do on the right-hand side of the right-hand equation would be to distribute the negative sign. You know how to solve equations like this. You know how to solve equations like this, so you can take it from there. What you need to convince yourself of is that it's this first part of the process that you need to commit to memory. Somehow, flashcards or Quizlets or I don't know what else is out there. I haven't had to make flashcards in a long time. But I'll tell you, you already know that one of the most difficult things about taking a math test is sitting there and looking at that problem and asking yourself, how do I start this problem again? But once you get the ball rolling, usually it's considerably easier. So make sure that in your study process, you're really focusing on, for this type of a problem, how do I get it started? For this type of a problem, how do I get it started? Oh, my hand looks really big. It's like the size of my whole head, right there. All right, now I'm just entertaining myself. What else have we got? Same idea. Once you clear the absolute value bars out of this thing and you've got it written as two separate equations, my recommendation is multiply the entire equation by 4. I'll write down the first one and then you can do the second one. So the first one says 1/2 x plus 2 equals, hold still, that was weird, equals 3/4 x minus 2. And then you're going to write down the other one over here where you got a negative in the parentheses and equals, and the other left-hand side is the same. But in this left-hand equation, my recommendation is that the first thing that you do is take this entire thing and multiply it by 4, or you can think of it as 4 over 1 if you want to. And when you multiply this equation by 4, what happens is that you end up introducing a multiple of 4 here, and a multiple of 4 here, and a multiple of 4 here, and a multiple of 4 here. Really? I have to take the 4 and distribute my multiplication? Yes. And then, yeah, this is going to reduce, and the numerator turns into a 2, and this one's an 8. And then what's the first thing that you're going to do here, I wonder? If you're thinking 3 times 4 is 12, that's true, but remember why it is that you introduced this multiple of 4 in the first place. It's so that it would cancel out with this 4. Don't mix the 4 and the 3 together. There's no need to do 4 times 3 equals 12. Just get rid of the 4's right away. And then this turned into a 2. Okay, so that's my recommendation for how to get that started, and a reminder that it's a good idea to clear your fractions right away and to multiply last. Why not make the numbers smaller immediately instead of making them larger? Same idea, except in this equation, you're going to multiply everything by 20. And when you multiply by 20, you will have to multiply this by 20, and you'll have to multiply the number 1 by 20, and you'll put this in parentheses and multiply it by 20. And then, are you going to distribute the multiplication by 20 right away? Please say no, please say no, please say no. Of course you're not going to. The first thing that you're going to do is take the 20 and you're going to reduce it with the 4 so that it turns into a 5, and then you're going to distribute it. But of course, before you do any of those things, you're going to rewrite this as 2 separate equations where this one looks just like the original but doesn't have any absolute value bars, and the second one, the left-hand side's the same, and then there's an equal sign, and then there's a negative, and then you put the whole right-hand side of the equation into here and distribute the negative. Then you can multiply by 20, right? Get the thing set up, break it up into the 2 equations first, then start cleaning it up and solving for x. That is called stuff. And when I take the absolute value of stuff, what kind of a number do I get? Technically, you get a non-negative number because you could end up getting 0. 0 is not positive. So if you were thinking, well, you get a positive number, well, most of the time you do, but you could get 0, and that's not positive. So you're going to get a non-negative number. But 99.9999% of the time, you're going to get a positive number. And this is called other stuff. And when you take the absolute value of this other stuff, what kind of a number are you going to get? Most of the time, a positive number. And what happens when you negate a positive number? You get a negative number. Is it possible for a positive number to equal a negative number? I think not. So what is your solution to this problem? No solution. It's the same as when we were taking the absolute value of whatever it was, and it was equal to like -3 or something. You can't take the absolute value of whatever it was and get a negative number. It just doesn't work that way. Same thing applies here in number 10. Hey, that's the end of the section. Those are absolute value equations. Use them wisely. See you soon.